right, so this is the last part of Unit 3, Day 3, Notes on Function Notation. And so we have composition of functions, or sometimes I'll say composite functions. When we have a function, we get some sort of an input that produces an output. But we can have an output that's just a number, or it can actually be a whole expression or another function. So when we have composition of functions, we mean we are combining functions where the output of one function becomes the input of the next. Okay, so here's sort of an example. This is g of f. That is just a circle, almost like the degree sign. So the g of f of x right here. Right, the g of f of x is also written up here. It really means to say the g of whatever you get in the f of x. If you plug in x into the function called f, then take that output and plug it in into your function called g. So the g of f of x, this is a g. I'm going to find out the f of x first. See, that's my first step. Once I have an output value, I'm going to plug that in as my input value for the function called g. All right, it is not commutative though. It matters whether you say the f of the g of x or the g of the f of x, so just be careful there. It matters what order you put things in. All right, so right here, I'm going to say let g of x equal 3x minus 2, and h of x equal x squared. So I want the g of the h of 2. So the first thing I can do is I can solve h of 2, right? I know that that means my input is 2 in the function h, and I'm going to find out what is the output. So if I want the h of 2 over here, I'm plugging in 2 because that's my input value. So it equals 2 squared. So the h of 2 equals 4. I'm now going to plug in, instead of h of 2, I know it equals 4, so I'm going to plug it in. So I'm now looking for the g of 4, right? I was able to find the output for h of 2. The output was 4. So now I'm going to look at the g function up here, and I'm going to plug in my input value. So the g of 4 equals 3 times 4 minus 2. All right, so I know that the g of 4 equals 12 minus 2, which equals 10. So the g of the h of 2 equals 10. I have to go back to the original whole question. The g of the h of 2 equals 10. I did h of 2 first and then used the output, and I found the function g with the input of 4. Okay, so over here we are in another order. This is the h of the g of negative 4. So I need to do the g of negative 4 first. Just work from the inside out, okay? The g of negative 4 first. So I know g of x. I'm just rewriting this so it's over on the same side, 3x minus 2. I took that from over here. I know h of x equals, x squared. Okay, so I want to work from the inside out. I'm going to do this g of negative 4 first. So the g of negative 4 equals 3 times negative 4 minus 2. So it equals negative 12 minus 2. So it equals negative 14. The g of negative 4 equals negative 14, so I can just plug that in now, right? So now I want the h of the g of negative 4, but I know the g of negative 4 is negative 14, so I'm going to plug it in. Okay, the h of negative 14 is what I'm looking for. I know from my original equation, h of x equals x squared, so whatever my input is, I'm going to square it. So I know the h of negative 14 is equal to negative 14 squared. All right, and 14 times 14 is 196. Negative times negative is positive, so my positive answer is 196, right? So if I want to go back to my original problem, I can rewrite this and say that I know the h of the g of negative 4 all equals 196. Okay, we're going to look at example 2. I have f of x here plus g of x. All right, so let's see if we can combine some like terms. They tell me that the f of x is 2x minus 3, so I'm just going to plug that in. 2x minus 3 plus the g of x. The They tell me the g of x is just negative 5x, right? So I have plugged in f of x, I know that was 2x minus 3, and g of x was negative 5x. And now I'm going to combine like terms. 2x minus 5x is negative 3x, and that negative 3 doesn't get combined with anybody. So my final answer, I just combined like terms. It's negative 3x minus 3. Over here, my f of x. I know f of x is 2x minus 3. I need to subtract the h of x. So I have to be really careful here, because if h of x has any more than one term, I need to make sure I make everything negative, or I'm subtracting everything. So I'm going to put my h of x in parentheses. H of x right here is 3 minus x. I put it in parentheses because I'm about to subtract everything that's in there. F of x minus h of x. So I know that I need to distribute this negative to everybody over there, right? So I have 2x minus 3 plus x. Negative times 3 is negative 3. Negative times negative x is plus x. So 2x plus x equals 3x. Negative 3 minus 3 more is going to be negative 6. So my answer is 3x minus 6. This is a multiplication dot right there, so I'm going to multiply f of x times j of x. Let's see what that looks like. F of x is 2x minus 3, and I'm going to multiply that times j of x, which is 9. Okay, that's a distributive property thing. I could put my 9 on the front if I wanted to see it that way. I'm just going to say 9 times the first term and 9 times the second term. So I'm distributing kind of backwards. 9 times 2x is 18x. 9 times negative 3 is negative 27. So my answer is 18x minus 27. All right, over here I have the f of 2x plus 2. That means my input is 2x plus 2. I want the function f. So back up here, this is f of x, right? This is the function f. So I start out with the f of x equals 2x minus 3. But I know that I'm going to plug in everything inside here. I'm going to plug in 2x plus 2 instead of x, right? Do you see that? This is my input, and my input needs to be 2x plus 2. So instead of saying 2x, I'm saying 2 times my input, minus 3. Pause and think about that. This whole thing is my input now, so that is what I'm plugging in instead of x. In order to simplify that, I'm going to use some distributive properties. So I have 4x plus 4 minus 3, and that's going to be 4x plus 1. All right, over here I want the g of the f of 7. So I'm going to work from the inside out. I'm going to find the f of 7 first. Once I know what that is, that's what I'm going to plug in into my function g. So f of 7 then equals, I'm coming right back up here, 2x minus 3, so it's going to be 2 times 7 minus 3. It's 14 minus 3, it is 11. The f of 7 is 11. So now I have a numerical amount that I can plug in, and I'm going to find the g of 11. Okay, so I come back up and I look, g of x equals negative 5x. So g of 11 is going to equal negative 5 times 11, which equals negative 55. All right, so I know the g of the f of 7 equals negative 55. And finally, I want the f of the j of x. So I'm going to start from the inside, j of x right there. J of x equals 9. Okay, so j of x equals 9. I know that because that's what my original paper told me. So instead of j of x, I'm going to say that I'm using the number 9. So the f of 9 equals, now I know my input is 9, and I'm coming back up here. F of x is 2x minus 3. So I'm going to say 2 times whatever x is. It's 9 minus 3. So that's 18 minus 3. That is 15. This means that the f of the j of x equals 15. Oh, and you couldn't quite see that. Let me try that one more time, sorry. Just that last little bit. The f of the j of x equals 15. I just rewrote my original problem and I wrote the answer that we came up with. Okay, so look for homework on math space and good luck.